We've already learned about arithmetic sequences in class, and now we're going to learn about geometric sequences. And geometric sequences are arguably more useful in your calculus future, so let's get started on them. A geometric sequence is one in which any term divided by the previous term is a constant. What does that mean? All right, so let's look at these two sequences. So this says if you have any term divided by the previous term being a constant, you've got a geometric sequence. So pick any term and divide it by the previous term. 12 divided by 3 gives you 4. And let's just see if that's constant, if that holds for all of the terms that we see. 48 divided by 12, that's 4. 192 divided by 48, calculator. 192 divided by 48, yep, that's equal to 4. All right, so this is a geometric sequence. All right, so it's defined in terms of division, but usually we think of it in terms of multiplication. So to get from 3 to 12, we would multiply by 4. Here we'd multiply by 4. Here we'd multiply by 4. So this one is geometric. So let's try it on the next one. So 4 divided by 2 gives me 2. 8 divided by 4 gives me 2. 10 divided by 8, not 2. All right, so if this falls apart on one pair of terms, it's just not a geometric sequence. So we're going to say not geometric. And this doesn't mean it's a bad sequence. It doesn't mean it's not useful. It just means it's not geometric. So all the formulas that we're going to learn for geometric sequences just won't apply to this one. That number 4 that we calculated for our geometric sequence on the last slide is what we call the common ratio R. So this is the number that you have to multiply each term to get to the next term. So let's find the common ratio for this geometric sequence. There's a couple of ways to do this. We can either think about the definition of a geometric sequence, where we're going to divide each term by the previous term to figure out what that common ratio is. So let's try it that way. So I'm going to take 1/9 and divide it by the previous term, -1/3. All right, so that's dividing fractions. We're going to keep, change, flip, or however you learn to divide fractions. Flip the -1/3 over, and then simplify. So let's see, the 3 and the 9 reduce to 3. And I get -1 on top and 3 on bottom. So that's my candidate for the common ratio. So remember that we can think about that ratio in two different ways. So in the definition, we were dividing a term by the previous term. And then I said we could also think about that as going forward in the sequence by multiplication. So let's just check our answer by seeing if this works. If we go forward in the sequence, are we multiplying by -1/3? And this ends up working out. If I take 1/9 and multiply it by -1/3, you get -1/27, which is the correct next term in the sequence. Just like our arithmetic sequences, geometric sequences can be represented in recursive form or explicit form. Usually we're going to like that explicit form a little bit better, but let's just get practice with both of them. All right, so this was the first geometric sequence that we had, 3, 12, 48, 192, and we figured out that the common ratio for this one was equal to 4. All right, so the recursive formula tells us that a sub n is equal to the common ratio times a sub n minus 1. This kind of makes sense, right? This just says if you want any given term in the sequence, look at the previous one and multiply it by 4, which is how this one works. We also know that for recursive formulas, you have to list where to start with the sequence. So we have to put in that a sub 1 is equal to 3. And then anybody can come along and build that sequence by using that recursive formula. The explicit formula, this one says a sub n is equal to a sub 1, so just the first term in the sequence, and then multiplied by the common ratio, 4, raised to the n minus 1. All right, and it has to be n minus 1 because you want that first term when I do a sub 1 to be 3 times, we don't want to multiply by 4 yet, we just want to get a 3. So that n minus 1 gives that first term a 0 exponent. We know 4 to the 0 would be 1. All right, so there's our explicit formula for that sequence. In the next video, we'll get some more practice using these two formulas.